Alright, in this video we're going to come up with a rule for the derivative of a general exponential function. So consider the function y equals b to the power of x, where b can't be 1 and b has to be a positive number. So in the previous video we came up with the rule for the derivative of the general logarithmic function. So to get the rule for the general exponential, all you're going to do is take this exponential, y equals b to the x, and write it in logarithmic form, which would be x equals log base b of y. So that's same function, but just in, sorry, not exponential. This would be logarithmic form. And then differentiate implicitly. So d by dx of x and d by dx of log base b of y, and the derivative of x with respect to x is 1. And we came up with this rule in the previous video. The derivative of log base b of y is 1 over y ln b, but we're differentiating implicitly. It's a function of y, but we're differentiating with respect to x, so we need to multiply by the derivative of y with respect to x. And then solving for dy dx, you're going to get dy by dx equals, multiply both sides by y ln b, and then replace, we want this as a function of x, y is equal to, remember, y equals b to the power of x, so dy by dx is equal to b to the power of x times ln of b. Okay, so that's our rule. So the derivative of b to the power of x is just equal to b to the power of x times the ln, or natural logarithm, of b. And that's your derivative rule. Okay, you could do a couple examples here. Say we wanted to differentiate a simple one, y equals 2 to the x, then that would be dy by dx. That's just a straight application of the rule. That would be 2 to the x ln 2. And that's the derivative of 2 to the x. Say we wanted to do one, let's make this quotient rule. Let's say 10 to the x divided by x. So there you got to use the quotient rule. So the quotient rule states you take the derivative of the numerator, which would be 10 to the power of x times ln 10, times the denominator minus the numerator, which is 10 to the x, times the derivative of the denominator, which would be 1, all over the denominator squared. So just simplifying that, you can factor out a 10 to the x on the numerator and get x ln 10 minus 1 all over x squared. And that would be a couple examples where we're finding the derivative involving general exponentials.